darlings, welcome to our video on gases in Unit 3. So for this video, you will need your notes, which is your pen and paper, and the periodic table. We're going to go through states of matter and intermolecular forces with each of the states of matter, the kinetic molecular theory, ideal versus real gases, and just miscellaneous gas information. So let's go through the different states of matter. We, of course, have seen these before. We have solid, liquids, and gases. Alright, so to draw a solid, if we're going to draw these little dots to represent each of the particles, I'm going to make sure that those dots are really close together for solids. They're not moving around too much. They're tightly packed and they're very dense. Liquids, on the other hand, are a little bit further apart. I usually generally draw these closer to the bottom because liquids, there's gravity. It's going to be at the bottom of the container. Gases, on the other hand, are going to be all over the place. So we will draw them all throughout. There's going to be they'll be very spread out and very random in order. All right, so these are the three particle diagrams that we would do for one for each of the states of matter. Now let's remind ourselves how to go from one state of matter to another one, and we'll cover this throughout the year just to make sure we get this. To go from a solid to a liquid, we're melting. To do the reverse, from a liquid to a solid, we're freezing. To go from a liquid to a gas, this is evaporation or boiling. We'll do evap here. Boiling as well. And to go from a gas to a liquid, it's condensation or condensing. If we want to go from a solid to a gas, that's sublimation. And going from a gas to a solid is deposition. Okay. So those are all physical states or physical changes of the states of matter. So let's talk about the gases. This whole unit in Unit 3 is dealing with gases. So we want to make sure we know what we're talking about. For gases off the periodic table, we'll remember the number 17. Okay, this one's super important. So let's figure out what that 17 was. The 1 from the 7 represents the first element, hydrogen. The 7 represents the 7th element, nitrogen. Then from that 7th element, nitrogen, all the way across, let's see if we can do this, all the way across and down, we create the number 7 in that table. You can kind of see that 7 right there. And element number 17, which is chlorine. All of these, in addition to He, helium, which doesn't fit into the 17, are going to be gases at standard temperature and pressure, or STP. So the intermolecular forces. Solids have the highest intermolecular forces, while gases have the lowest intermolecular forces. So solids will be really close together, whereas the gases will be very far apart. And the higher the mass of a particle, the higher the intermolecular force, and the higher the boiling point. And we have seen this back in Unit 2. I just want to remind you of these points. So let's talk about the kinetic molecular theory. So kinetic, like we talked about in temperature, is it's kinetic energy. It's the energy of motion, of things moving around. So gases are in constant random motion. The next thing is that particles move in straight lines until they collide with another particle or the sides of the container. And we've seen this with the PhET simulation from the temperature video. Particles are much smaller than the distance between them. So the gas particles, again, this is all dealing with gases. The gas particles are much smaller than the distance between them. Those gas particles are spread apart and they take up the entire container. Gas particles are so small that they have negligible volume, meaning that in the kinetic molecular theory, we state that the gases really don't have very much volume or mass. And the last little part is that particles have elastic collisions, so there's no attraction or repulsion between them. All of these things from the kinetic molecular theory are really important. These are easy multiple choice questions to get. They might say which of the following is part of the kinetic molecular theory, or which of the following is not part of the kinetic molecular theory. And just to let you also know, we abbreviate, sometimes I don't know if everyone else does, I abbreviate this KMT for a kinetic molecular theory. So all of these points of the kinetic molecular theory are really important to make sure that you know. So let's talk about ideal versus real gases. All of those parts of the kinetic molecular theory are for ideal gases. Pretty much what's going to happen under ideal conditions. Real gases in nature aren't always going to behave that same way. So real gases actually do have some volume to them, and they do have some mass. They also do have attraction between their particles. And small gases behave least like ideal gases. So the smaller the gas, the least ideal it's going to behave. And real gases behave like ideal gases under two conditions. So pretty much in nature, we can replicate what an ideal gas would be, in lab, we can replicate what ideal gases would be under two conditions. Now, this is another set of multiple choice questions that are really important. So, real gases behave like ideal gases when I think of this as my own self. So, my real life would mimic my ideal life under two conditions. So, this would be my ideal life, and if this were my real life, my real life would act like my ideal life under high temperatures and low pressure. You guys know me, you know I don't like the cold, right? So under high temperature and very low pressure in life, that's how my real life would act like my ideal life. Really cheesy and corny, I know, but just don't forget those. Alright, so some random miscellaneous facts. You've seen STP before. Up until this point, I'm like, ignore it. Don't worry about it in multiple choice questions. We'll get to it in Unit 3. Guess what? We're in Unit 3. So STP stands for Standard, Temperature, and Pressure. Standard means that we're going to have just one set of values. Temperature, the T stands for temperature. So that set value is at 273 degrees Celsius, or 0 Kelvin. And the pressure is at something called 1 atm, that stands for 1 atmosphere. All of these are also found in the front of your reference table, so in case you forget these values, they are there for you, so make sure that there's no excuse to not know them, because you'll have them on your reference table. And another thing that's really cool is that if you have two samples of gases that have the same volume, they actually have the same number of particles. So if I have one sample of gas that's 1 liter, and another sample of gas that's 1 liter, they each have the same number of particles to them. And at standard temperature and pressure, there's special values here that we need to know. A unique value is 22.4 liters. Okay, so think about a liter of soda. Just do 22.4 of them, put together, is equal to a mole of particles. So a mole of particles is 6.022 times 10 to the 23rd particles. So you've probably seen that big banner outside of our classroom that has the 6, the 0, the 2, 2, and all of those zeros. That represents a mole of particles. Just like if you said you had a dozen eggs. A dozen eggs would be equal to 12. Okay? If we had a couple of pencils, that's equal to 2. Right? So if we have a mole of particles, that's equal to 6.022 times 10 to the 23rd particles. And that's all at 22.4 liters. So these equivalencies are really important to make sure that you have and that you know. And these are not going to be in your periodic table. So for a quick summary, gas particles have low intermolecular forces. Make sure you know that all those little postulates of the kinetic molecular theory. Real gases behave like ideal gases at high temperatures and low pressures. Remember my life. My real life would mimic my ideal life if there were high temperatures, if I had high temperatures, and low pressures. Sorry about that, darlings. Okay, there we go. And let's see. STP is standard temperature and pressure. Make sure you remember the values for temperature and pressure. Temperature is 0 Kelvin or 273 degrees Celsius. And pressure is 1 atm, and that's found on the front of your reference table. And the amount of gas particles depends on the volume of the container. So, again, 22.4 liters, or 22.4 liter container, will equal 1 mole of particles, which is equal to 6.022 times 10 to the 23rd particles. Alright. Okay. So that's it for all the basics of gases. We're going to be dealing with this all throughout Unit 3. And so let me know if you have any questions. Take care. Bye.